Good evening to all of you. I am Raghavan from ISHRAE Technical Committee. We are very happy to have all of you for this session on cardiovascular thoracic surgery room HVAC design aspects. This series we are having in 3 parts, and today we are having the part 3. The part 1 and part 2 has got tremendous response, keeping all of us quite interested in the subject to learn more. The objective of this ITC webinar is to bring experts from each specific domain so that we get access to them. We are able to learn from their experience and wisdom. So I'm sure this particular series also will help all of us to understand all the key aspects related to the cardiovascular thoracic surgery room design. One request to all of you, if at all you have any questions, you may keep posting them on the chat box, and towards the end, Mr. Niladri Mukherjee will be able to answer them. A quick introduction about him, the speaker. Though many of you may be familiar with him having attended the part 1 and part 2 session. So he's an industry veteran with a specialization in a particular healthcare domain. He has worked for quite a few big MNC corporates, veteran with more than 40 years experience in the field. He also is an advisor to hospitals on cost-effective and infection-controlled HVAC solution implementation. He also has been part of the panel which came out with the standards on operation theaters and IVF clean room standards for South Asia. So with this little background about him, I hand over to Mr. Niladri to take us through the part 3 of this series. Over to you, sir. Yeah. You may answer the queries towards the end of your. Thank you.
Good evening. Good evening, everyone. See, this is the part 3, where actually the heading is Cardiovascular Surgery Room Design, HVAC Support. Now, at the bottom, you are finding that there is a word written TRR. So this is TRR is very critical for cardiovascular thoracic surgery room and in terms of HVAC design. Now, this is actually a very lengthy sessions. If you can explain the design formats and the equations of engineering equations which are involved, but it's not possible in this 45 minutes. But I will try to build up some concept so that people understand, and if anybody needs further knowledge, they can write to me. It's a long sessions. Now, this is a message which I like to give it, that for whom actually we are developing this program. This is primarily for the hospital HVAC consulting organizations, hospital consultant, and hospital planning consultant. There are some consultants that will do the planning of hospitals. So I hope that this will definitely help all the consulting organizations. Now, before we go into these details of the subject, this hospital HVAC design needs detailed clinical knowledge. See, without a clinical knowledge, the HVAC design cannot be established, because HVAC design and the clinical knowledge of hospitals are both linked together. So this is very important. So when I've been going into in the deeper of the subject, we'll find that many medical terminologies will come. We cannot avoid that. So what we have made, actually, we have made part 1 and part 2, entire cardiovascular thoracic surgery. This is a part 1. Very shortly, I'm telling you, even I have earlier also told that we find that Indian corporate hospital sector by 2030, it will be like around 173.63 billion, it is expected. And there are many corporate hospitals are there. and they are all get funded by the PE company. They are private equity company, most of American companies. Now, this is actually, you see, this is South Asian hospital tourism. Now, this is those who are into the business of hospital business, it is a good opportunity for them. If they make expertise in this segment, definitely future is very bright. See, it is found that in terms of South Asian countries and part of South Central Asian countries, India is a place where advantage in terms of climates, in terms of language, food habits, and even also the economically, it is much better compared to very advanced countries like Singapore and Hong Kong. So this is actually the focus. So everybody is driving on that one, maybe after 5 years, India will be a major hub for South Asian countries as a hospital segments.
Sir,
very shortly, I'm
you
telling
have
you
to share your
main.
Sir, we are not able to see your screen.
Oh,
you have to share your PowerPoint.
1 minute, 1 minute.
Yes, sir.
That is okay.
Yes, sir. Visible. Please proceed.
See, 1 minute. This nosocomial infections and toxic gases, these are the two challenges in hospitals. Even when you deal with the pharmaceuticals manufacturing, these challenges are not there. That infection and toxic gases, they mainly work on a clean room. So we have made two parts. I'm telling you, when the time will proceed, will go with some depth of knowledge will increase. The major thing is that which we are telling that in case of cardiovascular thoracic surgery, we are recommending that don't go for a thumb rule, primarily on room load design and modulation. This is very important. If we make a mistake in the room load design, load means it is not the heating, it is a heating, cooling, and the moisture load. And then it is coming the modulation. So this is a process which is actually to be done at the very beginning of the project. This is very, very important. When I'll show you the other slide, we'll explain to you why the modulation and what is meaning the modulations. This is very important. But thumb rule, like there are some thumb rules are available in the industry. I request that please avoid for this type of thumb rule, particularly in terms of cardiovascular thoracic surgery. So when we'll be proceeding, we'll find a lot of problems areas, but our objective is not to discuss on the problem. We'll find the solution, engineering solutions, so that the projects in the hospital project is successful. Now, this is very essential. I mentioned that EPR, or it is somebody say EPI, energy performance ratio. This is basically the total kilowatt per hour of a building divided by the built-up area. Now it is found that normal commercial building, like from office to an airport or even a mall and other, it is around 300 to 350. It is okay, but in case of EPR, in case of hospital, it is very, very high. And if you separately think about room-wise, like this cardiothoracic surgery room and others, or surgery room, EPR is much, much higher. Why? What is the reason behind that? You see, green building people, if they can objection, or there is a ECBC has made some guidelines on National Building Council. These cannot be brought in case of hospital design or disturbs of critical area of hospitals. Medical appliances need 24 hours HVAC support. Surgery room needs 24 hours support. Critical zone needs 24 hours support. Now, in case of hotel, what we do now, most of the hotels, standard hotels are coming into that. There's a single point power. So when you are removing the key, the entire room gets off. But this is basically for controlling the supply of power energy. But this theory will not be applicable for hospitals. So this is another very important thing, that is a hospital flow system. When you are going into the design of an hospital, the hospital flow system should be known to an hospital consultant. And there is a very important thing, that medical practitioners, when they talk, even they talk through a vendor or a supplier, they always try to use the medical terminology. So it is always expect that the supplier or other, they also will communicate in the same language. Otherwise, there will be a gap. That is why I've been telling that these medical terminologies and others, the hospital flow system should be known by the consultant if he wants to develop a hospital or has become a hospital HVAC consultant. So we are going into part 2. I'm going fast because we have no much time. See, go through these slides. This is a very basic thing of a surgery room specification. Dry valve temperature, wet valve temperature, wet valve depression, RH. Now you see, point number 5, I made WG by LB. It is basically grain per pound. I will explain you what is a grain per pound versus RH. Why these two are very critical and separately to be analyzed in case of a surgery room or any critical areas of hospitals. 6th is a thermal plumes and thermal plume density. Now, what is this thermal plumes? When a surgery is happening, it is basically use the diathermy machines, cautery machines. Now, this cautery machines, it have a different wattage. It generates a huge heat. I will show you the thermal map, how much heat is generated on the patients. It is not only the heat which is generated, it is a major area, it is major job for an HVAC consultant that to remove that heat. And in case of CVT, cardiovascular thoracic surgery, it is critical further because it takes a lot of time, 12 hours, 14 hours. So one is a surgical flume. Then ACA, air change per hour, air velocity. Air velocity is very important. Apart from CFM, we advise to calculate the air velocity. Room total pressure and room static pressure. And now it is, again, I'm telling you, we don't have much time, just giving you a small room static pressure. We advise to all the consultant, even in the training session also, to calculate separately. Why? If the static part is become very high, it is not good for the health. In normal case, static part should not be very high. CO2 level, VOC level is very important for surgery room. Is a volatile organic compound. Differential pressure, static electrical diffusion rate. Because you see, if I compare with an office or a mall or an airport, airport is a very large commercial area, but you will not find such electrical diffusions. But if you have an idea of a surgical room, there are a lot of electrical gadgets. So they generate diffusions. So it is a major task to find out what are the gadgets to be used, and this has to be removed through an earthing. Otherwise, it will create problem in the other gadgets. Air stratification, very shortly telling that air having a different layer of temperature. It does not mean that I am saying the room temperature is 24 degrees centigrade. Entire room is 24 degrees centigrade. There are different layers there. So this air stratification is to be under control. Flow type is very important. Is it a turbulent flow or mixed flow or it's a laminar flow? Particle counting rate is a clean room standard. Is also very important. Type of refrigerator and permissible CFU level. This is, unfortunately, my experience in India, even in Bangladesh, even in Myanmar, this area is absolutely neglected. This is called CFU, colony forming unit. This is very, very vital. Now we are finding that I made it TRR. I'll explain you what is a TRR. TRR at the rate of heart lung transplantation. CO2 level, it is also measured by the PPA. I will explain you TRR. Now you see, nowadays in case of these types of critical design, along with the ACPH, air change per hour, We also recommending to separately give the outside air change rate. So this is along with SCPH. Separately, it is asked to mention the what will be the outside air change rate. Now, before we go to this TRR thing, what is TRR? TRR is a major thing in case of cardiovascular surgery. Now let us understand some clinical procedures, because without that clinical procedures we cannot go into the HVAC design. There are 4 type of temperatures comes in clinical system, medical system. One is called non-invasive pressure. Another is the invasive pressure, non-invasive temperature, and is the invasive temperature. Now you see, I make a tick. Invasive, what actually we do, we take the pressure, this is a non-invasive pressure. But invasive pressure is very important, which we taking from the blood directly. Second, same thing, the temperature which we take from outside, that is a non-invasive temperature. But in case of cardiothoracic surgery, this invasive temperature is very important. There are some method to take the invasive temperature, but normally surgical and vascular catheters are used in case of open heart surgery for getting the invasive temperature. Why invasive temperature is important? So slowly, let us understand this. What is cardiovascular thoracic surgery? It is called CVT. Now you see, cardiovascular. Cardio means the heart. Vascular means the vein which carries the blood. And thoracic, actually, thorax is coming for the lungs, this cavity. So it is also the heart and lungs together. That it is called a CVT. Now what is TRR? Why TRR is important in case of cardiovascular surgery? It is only applicable in case of cardiovascular surgery. Now what happens, you just see, these doctors normally they go with a temperature, room temperature of around 18 to 19 degrees centigrade normally, or 20. Why? What is the reason behind that? Because you see, the surgeon, they wear a lot of clothes where CLO is very high. That is why they prefer to have a lower temperature. Now in other surgery, normal surgery, this will not have any problem on the patients. But when you are doing open heart surgery, this is a completely different environment. You see, when the temperature of a body and temperature inside bloods, these both temperature becomes very low because it is open, and I've kept the room very low. That is point number 1. Point number 2, how this lungs, open heart surgery is surviving, lungs and heart. It is basically controlled by heart-lung machines. It means, very short, it is the heart and lungs is under functions. Along with that, the ventilation support is also there. So you see, in terms of these types of surgery, it is absolutely artificially it is happening. Now, when the surgery is over for 12 to 14 hours, normally it takes something like that. If you do the sum up in stitching and everything, then there will be a lower, inner body and outer body. This will be a temperature gradient will come. And when you are removing the patient from the artificial system, it means from the heart-lung machine and others. During that time, because of this inner lower temperature, there is a possibilities of hypothermia effect. This is only applicable for these types of open heart surgery or cardiovascular thoracic surgery. See, heart and lungs, if we see, these are the two main body, which actually what is a AHU, your lungs, which actually, and heart is a pumping. So these two are making alive. So other part of the body, when surgery is happening and other, it is not so important than an open heart surgery. So the problem may happen, that is called the hyperthermia effect. Now what is TRR? TRR is actually only used in these types of cardiovascular surgery. What is the full term of TRR? Temperature recovery rate. Let us understand what is this. Now, when the temperature is very low, I have to, and the doctors are removing all that artificial support from the patients. The patient should be allowed to get temperature higher, which as per the clinical temperature to be brought, which will be supporting the patients. So this is a task for our doctors or the medical team, so that the patients will be able to survive and overcome the hypothermia effect. So this is a very important thing, the TRR, which is to be incorporated through an HVAC design. Now, this design procedure which I'm showing you, this is basically not for the cold country. It is not applicable for North American country or even in European countries. This is basically tropical countries, hot, humid climates, or even hot and dry climates. So majorly in India and surrounding like Bangladesh, Myanmar, Sri Lanka, these are not a very cold countries. This design procedure can be applicable there. The step one, what is the first step we are saying? It is a normal international system is that when a CVT room, surgery room to be designed, a project design and clinical performance index report to be developed. I am telling not for India, but Bangladesh or other. It is for the internationally system is that a project design and clinical performance index report to be created. This either by a consultant, HVAC consultant, or both together, and this report has to be generated. That is the first thing. Now let us understand this cardiothoracic surgery. This is actually governed by the Society of Thoracic Surgeons. They are US. They are the mother body. Under it is called STS. Under STS, there are small other surgical associations of America. But they are the mother body. What they are doing is they have given some guidelines. And again, it is not a standard. They have given some guidelines how a cardiac thoracic surgery room to be designed. It is not only for engineering way. It is clinical and engineering together. That this is the way the cardiovascular surgery room to be made. In between, ISHRAE also has come because ISHRAE has developed a lot of standard, but not particularly for cardiovascular surgery. So ISHRAE has already given some guidelines for surgery rooms. The American Society of Healthcare Engineers, all together, they also supported, and some general guidelines has been developed for these types of critical surgery like cardiovascular surgery. So what I was telling earlier that in these types of surgery room, the building load modulation is very, very important. If we go with some hypothesis or you go for some thumb rule, it will be really a problem. You see the critical area which I mentioned, that is TRR, temperature recovery rate. So temperature and it is cooling or heating together is the thermal load of a building, of a room, and the moisture load also there. This has to be calculated very carefully. Then after that, when the design is happening, a modulation is there. Modulation is required. What is a modulation? I'm telling you. Actually, CTV, it is somebody's a CTV surgery room design modulations. I'm explaining you in short. I will explain you. Now you see, along with that, there is called medical appliances and technology support, dedicated thermal system. What is this? You see, there is a medical practitioners, doctors, surgeons. They are not alone. They cannot do anything unless they are supported by the medical appliances. Somebody say medical equipments, but we say it's a medical appliances. These medical appliances and these medical appliances which are used in the surgery room, they are extremely sensitive. Now, all these machines are coming with temperature and humidity setting. So this needs, because it's a separate subject, it will take a lot of time to explain you that which I mentioned, that dedicated thermal system, which is required for these types of gadgets which are used in cardiovascular surgery room. So important is that let us understand this, that dedicated thermal system is required to support all the heart lung machines, invasive ventilator and everything. Now see how we'll proceed for the design. These are the major points: accurate thermal and moisture load design for the CVT room. This is very, very accurate. It has to be done. If there is a mistake, if there is a variations much, then there will be a problem. I have not explained you that what I have told the modulation. I will explain you the modulation. Design of a surgical flume density and smoke density. Yes, what happens? Those who are aware of the surgery system or seeing the surgery, they use the cautery machines or diathermy machines. Now, every diathermy machine have a different wattage. They generate heats. Along with the heat, it generates smokes. Now, in case of cardiovascular surgery, it's a very long hour. It's a bone, it has to be cut, everything. So it's a long procedure. It's 12 to 14 hours. Right now, these types of thermal flume will continuously remain on the patient. It will be not good. So, a job for a consultant or a HVAC consulting designer to remove that flume regularly along with the air system. Second is the smoke density. It is called SDV. It is called smoke density volume. It generates smokes. So you understand, even in the surgery room, you are generating a lot of unpure air. It's a burned air you are creating. So this air is a smoke. If you say smoke, this and the heat which is generated on the patient table need to be removed. So this is a challenge for HVAC designer, HVAC consultant, so that it supports the patient, it doesn't create any problem on the patient. Now, if you ask me, the other surgery room, why it is not taken care of other, see, the same thing will happen. But what is happening? There actually, the time period is very, very less. Time period is very less. Here it is around 12 hours to 14 hours is take place. Then CVT room load modulation, I'll explain you. Medical appliances, dedicated thermal support. That I have told you that why they need a thermal support. Electrical diffusion and earthing design. And infrastructural support. Basically, it's a clinical. This also I will explain you separately. Accurate laminar flow. It is recommended that RE, that is a Reynolds number, should be at least below 2300. At least. Pressurization controls and airlock. And this is the design I will show you, that customized AHU design 3+1 system. Outside air with a treated fresh air unit. It is recommended internationally that, though in India, Bangladesh, Myanmar, we don't find, but internationally it is recommended to use cardiothoracic surgery room ISO 5 standard. If just understand, a patient remain in a surgery table for 12 to 14 hours. Now, what is a modulation? Very shortly, I'm telling you what is a modulation thing. Modulation, these types of so accurate calculation is not required for a office complex or a mall or another. See, it's a correct figure in last year, which Delhi is showing around 52.9 degrees, a peak temperature, and the minimum temperature of Delhi came around 7 degrees centigrade. Now, this temperature for this 52 degree temperature, 52.9, it was for the 3 days. Very shortly, I'm telling you, this is very, very alarming for a HVAC consultant, because you see that load is varying from 52.9 to 7. It means this type here, if in Delhi, you make a hospital, you need a cooling, you need a heating both. So both this heating and cooling to be together in a design. Simultaneously, you have to understand what will be the peak temperature I will take. Along with that, the moisture also is coming. Now 52 degrees centigrade coming for 3 days. Now naturally, you can, and 44 degrees centigrade is coming for 37 days. So it is it depends on the application wise. But in case of surgery room, hospitals and others, you have to go accurately. If you give some allowance there, then there is a chance of there is a problem. So very shortly, I'm telling you, this modulation is a separate mathematics are there, calculation method is there. How we'll make these modulations? RH temperature issue is very important. I find that people say that RH this or temperature this is not that. As per the psychometry chart, if you go RH and temperature there is no mathematical relation between RH temperature, but it is fine that if the temperature reduces in the psychometry chart, RH slowly increases and going towards the condensation. So when you will be saying that temperature, we should also say the RH, or if we say the RH, then you should also say the temperature. If we isolated RH and temperature, then it has no meaning. Technically, it has no meaning. So the moisture load, so what I was telling you about the thermal load, we have to add the moisture load. That is called grain per pound. 1 grain means 1 pound means 7,000 grain. So this is called a modulations. So this is a very important factor that is called climate swing factor. Now, in India, there's a National Building Council. They have made some 5 zones: hot and dry, warm and hot, something like that. See, most of this North India, from Delhi, you go to UP and this area, they are either hot or dry, or it is very hot or they are averagely hot. And there is a temperature change is very high from winter and summer. This is called climate swing factor. There is a calculation methodology is there. You can take the help of psychometry and others and the data book. So you can find out the climate swing factor when the building load design is happening. This is called CSF to be incorporate. In these types of surgery room, cardiovascular surgery room and other, we recommend very cautiously to do the load design and incorporate climate swing factor. This is a picture of a North Indian private hospital. You see that it's a winter. This blanket is not from the hospital. It is coming from the patients. It means it's ICU. It's a pulmonary disease patients are there. So it means clearly that temperature, there is no heating arrangement in the winter time. This very clearly. And again, I'm telling you, technically and clinically, the patients get affected for the lower temperature, those who have a CVC, those who have pulmonary problems. They have definitely have effect will fall on them if the temperatures comes down. So this should not be allowed, which I want to tell you. So you should incorporate heating and cooling both to maintain the temperature, design temperature as per the clinical temperature. I'm advising you, please do not use electrical heater. It will take a lot of time. Why I'm not recommending electrical heater, but it is very dangerous. If you use an ICU or hospital in a winter period, season, the electrical heater, burn out oxygens. And it creates many other problems there. So my advice to all the consultants, do not ask the hospital people to use electrical heater. So this is a psychometry chart where you can calculate the climate swing factor. We don't have time, but climate swing factor is basically can be calculated from psychometry chart. Now you see the CVT surgery room. It is very important, is coming with the pressurizations and ventilations. Very, very important. You need to give a pressure and you have to control the pressure systems between the rooms. So this is actually a cascade type of airlock where the main core area is a higher pressures and side one is the main side one is a higher pressure and middle one is a lower pressure and side one is a further lower pressure. So this is a this is the way actually the cascade airflow is followed in terms of surgery room. Now, let me explain to you that when we have mentioned that room pressure and we have mentioned that total room pressure, normally the total room pressure between the two walls. How is the pressure exhibit between the two walls? So this is actually the it is a room pressure, and differential pressure is a different thing. Is a pressure between the two rooms. Now, why it is so important when I'm designing a room pressure? The room pressure depending on the CFA. So naturally, every HVAC consultant design what will be the CFA, which is coming from AHU to the duct and to the room. Now, this CFM, what actually the design CMA required, it is not effective CFM in the surgery room. Why? You see, this is the formula K into CFM square. It means more CFM, the room total pressure will increase. But actually, what is a K factor? It is called resistance to air. Now, you see, this resistance to air in case of these types of surgery room, where a lot of gadgets are there, this effective CFM will be less. So, for designing a CVT room, consultants should consider this K factor. So, this is actually the cardiovascular thoracic, more in details. Now, there are some procedures are there for cardiothoracic surgery room. One is the infection control, and the airflow system, ACPH, environment requirement, and we are recommending that it should be automation. Unless there is automation, you cannot maintain so many parameters which I had shown. Medical infrastructure and technical HVAC support. It means these types of surgery room have to give some medical infrastructure. Now, what is this? Let me understand now. Going to procedure 2. What are the medical infrastructure? Without this medical infrastructure, a HVAC consultant cannot design. It is said minimum 950 square feet. Minimum 950. Now, I'm just telling you, this is a Singapore consultant. They have made some guidelines for cardiothoracic room. And some American surgical society altogether is an average. The recommendation is 950 should be the clear floor. Duration coming around 12 to 14 hours. Manpower sometimes is come around 4. Assistant physician 2. Anesthetist 2. Medical supporting some 6. These are all some guidelines. This is required. Supporting medical appliances. How many medical appliances are required? You understand that how much electrical diffusion can happen. Biophysics defibrillator 2. Invasive ventilator 1+1. Heart-lung machines. 7 paramonitors. SpO2 digital reading with seismograph, ETCO2, HR, patient skin temperature, NIBP, IBP, probe, ventricular probe, actually ventricular fibrillation probe. This is called VIPB. So you see, these are all medical terms. These all the surgeons or they are medically, these has to be there in these types of cardiovascular thoracic surgery room. It is not HVAC, but they are all medical appliances. They are very critical appliances. They need a thermal support. And second one is called the bipolar cautery machines. I don't know how many people are knowing this is recommended to use bipolar cautery machines. Now, these bipolar cautery machines are expensive and they are more precision. This has been found. This cautery machine which are used on a surgery room, their watt come from 300 to 400 watt. So you just imagine how much heat is generated. It has been found that on the patient body, 1365 BTU per hour heat can generate on the patient's body. So it's a job for a consultant to remove that heat. And it's a continuous process. And surgical flume density, which is actually 95% water and steam. So along with that, there is a smoke density. So smoke density also to be calculated because the smoke to be removed through air only. So this is actually see, this is the situation. So open heart surgery. The surgery has not started. How many machines are supporting these patients before the OT is started? So it's a absolute and artificial system. Now we'll go more into the TRR. Now it is the procedure 3. It is say, see, I told you the GRT consultant, they have come with Singapore. They have given some guidelines. They are recommending 40 to 60 will be the air change per hour. Laminar planar with HEPA, which is H13 or 14. And all the body should be 306, SS306 body. 3 airlocks, very specially they have mentioned 3 airlocks, surgery room, post and pre-surgery room, 2 airlocks. Surgery area should be around main core area, 25 Pascal, and post-surgery room will be 20 Pascal. Doctors change, doctor and staff changing room 15 Pascal. So you see there are a lot of directions are there. Now use the AHU, they have mentioned a 2-drain pump, pain. Why 2-drain? Because I have been asked by some consultant why you are recommending 2-drain. Because you know this when the load is high, when the it is a tall coil, it is always better to give a 2-drain pan so that the water cannot split to the room and to reduce the evaporating rate inside the room. So air certification rate also they have mentioned that it between 10 to 15%. So it means a fluctuation of temperature. AHU double skin and thermal break, which is in AHU should be 50 mm. UVGI is very, very essential. All I will show you. The UVGI should be there. And outside air change rate, I told you that apart from ACPH, outside air changes separately now you are mentioning, it is 6. So that's fresh air treatment to support the main HU. So there will be, I'll show you in the diagram, there's a main HU, which HU will be supporting the surgery area, post-surgery area. There is a heat pump and electrical boiler. Capacity depends on the heating. HU to support the fresh air and support the mixing box. Fresh air inlet automatic damper. Automatic damper arrangement at a hot air supply and to be connected with the hot air. Anyhow, this I will explain you in the diagram. Here actually one main important thing that apply scroll chiller. Why they are recommending a scroll chiller? Because one area is that which if there is any electrical breakage and others, if the entire surgery room under a single chiller plant, there it will be difficult for a chiller to run without any power because you need a very heavy generator. Say 200 to 250 chillers will be difficult. So it is recommended that use scroll chiller. So entire load, I was been telling at the beginning, the load calculation will be separately for these types of CVT surgery room. Apply scroll chiller, air-cooled scroll chiller, which is better than DX system and more controllable, can operate during the power if the failure of power. Magnetic gauge in each door. And automation of the different sensor and others. So you understand that even have to read out all these, it will take a lot of time. Why laminar airflow design? Now, just telling you, laminar flow now is very standard for all the surgery room in India also. But it is not easy. Even I have asked some American very senior consultant of actual perfectly design of laminar flow. It's very frankly telling the answer is difficult. Even he couldn't give answer. It is not possible manually. This laminar flow, why we to protect the patient from contaminations. I will explain you why laminar flow is so critical, and there is a colony forming unit is linked with the laminar flow. We are recommending to use computational fluid dynamics for designing a laminar flow for any OT, not only for that cardiovascular surgery, for any OT. See this equation, I'm explaining you, those who are here with listening this is a very basic fluid dynamics equation, which is density into velocity into length. And this mu is basically the dynamic viscosity. Now, if the Reynolds number, RE, it should be below 2000, or at least we are saying go up to 2300. If it is not happening, it means the air which is coming from the AHU to the duct and from this box, HEPA, that is a laminar plenum box, then our objective is 25 feet to 30 feet per minute. That should be the velocity of the air along with the laminar flow, 10 centimeters from the laminar plenum to the patient table. Now you see how many variables are there to maintain RE. If we don't maintain RE below 2000 or 2300, it will not be a laminar flow. Now, the major tricky thing is that this viscosity, which is a dynamic viscosity, it is variable with the temperature, but it is different weight variable. When it's a fluid, it is inversely variable. When it's a gas, it is directly proportional. So, until and unless I have a control of all these parameters, length is fixed, length there is no, but velocity will change. If I see that density also here is also same, but major challenge will come with the velocity and the viscosity. Which velocity will be considered in the design, which is coming from the HU to the duct, and finally which is entering to that HEPA filter box. Pena. Now you see this is the picture which is coming. That is a duct system. It is coming to the HEPA laminar pena. Now, until and unless I have control on this parameter, I am not able to control the RE. So it is difficult. Now, major tricky thing is that if the laminar flow, it's a genuine laminar flow, then 10 CFU per ml, which is called the infection density, it will be within 10. If the laminar, it is said in the research that if the proper laminar flow is made on the patient, then the spreading of infection, which is defined by CMU, 10 CMU per ml, it should be within that. So this is why the laminar flow is important. Just for laminar flow, laminar penam I will put up on the patient's body on the ceiling. It does not mean the laminar flow will happen. The objective will be actually you will not be able to meet the objective. So please note down this thing. In a proper laminar flow, it is said in the research that it will be between 10 CFU per ml if the laminar flow is okay. So for this types of CVT room, you have to use a computational fluid dynamics because these are all very variable. I'm going to the diagram. You see, I'll show you 4 HU. HU1, HU2, HU3, and HU with a heating coil. These has been guided by, I'm telling you, this Singapore consultant. They have developed for our big hospitals. So for the cardiac surgery room. So I'll explain you now. See, go through this. This is a very small, very simple way. This is a core surface area. It's a big challenge for a consultant and doctors, everybody, that the surgery is for 14 hours. What happens? There is a corridor, there will be a pre-surgery room. It means that it is a complex. When you are making a CVT surgery room, it should be. I'm again telling you what I'm happening in India, I now don't want to discuss. But actually what should be, it is a pre-surgery room. So this is the doctor's changing room and this is the nurse changing room. Very simple way to explain. And this is the corridor. This is a core surgery area and this is the area where we are finding the post-surgery room. So our objective is an architect who will make the layout. He has to give all the facilities. One is the doctor changing room, nurse changing room, pre-surgery room, post-surgery room, and the surgery core area. Along with that, you are finding these are all airlock. A1, A2, A3, these are all airlock. And this side also A4, A5, A6. So this is the very basic layout of a CVT surgery room, must. Because you cannot take a patient from the surgery room direct to the bed. So there you are finding that these all the other separate doors are there to keep this. So this is a HU. First, I'm putting up a HU. HU1. This is coming to the laminar flow. This HU is a dedicated HU for the surgery room. Then there is a HU2. There is a HU2. This HU2 is basically, it is connected with a heat pump. Now, in internationally, electrical heating is not recommended. It is through a heat pump or a refrigeration heat pump. It is normally we recommend for a refrigeration heat pump. So this, I made it a red color. It is for the heating, and exclusively HU2 will make for the heating arrangement. So what we are finding, why we are finding one HU1, which is for the surgery core area, and there is an HU2. So this one will give you a laminar flow stations. This HU1 which is supplying. Now there is a HU with a heating coil. This heating coil is basically either use a heating coil, or this is basically through a heat pump. The third one is HU3. Now what is happening? HU3, it is supplying to the two areas. One is a pre-surgery room and the post-surgery room. So I cannot show all these. These are, so HU3 is made to support PSR, I mean pre-surgery room and post-surgery room. Now you see how is happening. This HU1 which is coming, this is called CVT Surgery Room with a HEPA, it is coming. This is a V1. What is a V1? I'm showing this is a VAP box, variable air volume. I have explained you in equation that CFM is linked with the pressurization. More CFM you give, flow rate will increase, your pressure will increase. So V1 is a variable air box. So this HU, which is for the airlock, it is also with a VAP box to control the pressure as per the design pressure. Now this HU, which is with this HU, HU1 and HU2, this HU which is the heating, which is basically doing the heating, it also have a UVGI, and HU1 it is also have a UVGI. Now this HU is also should be supported with fresh air, and HU1 is also supported with the fresh air. Both will be supported with the fresh air. Why? Because you see, when the surgery is over, when the doctor is understanding that after half an hour or 40 minutes, entire artificial system will be withdrawn and stitching will start take place. By that time, this temperature of the inner temperature, which is invasive temperature, will rise. And the clinical word. So to increase that, this HU1 will stop. Then because room temperature is very low, then it will be coming to HU, which is heating coil or UVGI. Now this is also parallelly function with HU1 and this. So it also protects the entire infection and everything. So all the dimension, all the specifications of HU1, which is the core, both are connected to the main area. So these FHU also should have a UVGI. Now this is a critical area. When the HU will come, it is actually through a sensor. So if the heat pump is there, it will pump and it will stop. So you are understanding that how many airlocks are there, plenty of VAP boxes are there to control the pressures. So automation design should be incorporated in HVAC design. So see this which I have been showing you, so many things are there in case of air gadget. One is a variable air box. One is your airlocks which are coming. They have their different pressure segment. Then HU1 and this, they again will remove. So HU3, which earlier I showed, they will be supplying to this post-surgery and pre-surgery. This here UVGI is not required. But where we are saying that 40 ACPH, which is mentioned for HU1, it will be have a reduced air change rate, not 40, 20. So there are many methods are there for automations, but very simple way which is recommended that PLC board should be there in the surgery room. It's a panel, control panel, where few of the doctors or technicians, whatever be, they will be understanding so many parameters are there. Pressure, temperature, all these things, and the differential pressure, everything. So this is very important, because this cycle which I'm showing you, so many variable airbox, so many AHUs, all has to be under the automation. Unless the automation design incorporate these types of complexity or these types of complicated design will not be able to run. So, this subject, I'm telling you, it's a very large subject, but since we don't have much time, so I went very fast. If anybody, any other questions, you can ask me or you can write to me.
Sir, thank you very much. Please look at the question box as well as the chat box. There are few comments and questions you may answer. Once that is done, we will open the whole thing session up in case anyone wants to ask verbally their question. Could you please look at the chat box and the Q&A box, sir? Yeah. Okay, let me read it for you. On the question and answer tab, there is one query from Mr. Narendra. Do we get participation?
It will be better if they ask me, that will be better.
As of now, we have not facility. Meaning you want them to ask you, sir, verbally?
No, if you can, somebody, if you can ask them to
directly,
unmute and ask me
on audio. We have to unmute them. Yeah. So whoever wants to ask any question, you may please unmute. Aarti, is that allowed for the participants to unmute and ask the question?
Yes, sir, it's fine. Ali sir has raised his hand. Okay. I have allowed him to speak. He just has to unmute himself.
Yeah. Please unmute and ask. Say your name and if possible, organization and location, so that all of us get to know about you. And then you may put your question to Mr. Niladri. Thank you. Please proceed. Hello, participants. Am I audible, Aarti?
Yes, sir, you're audible.
Okay, usually there will be some hesitation, not an issue. Let me read the questions. Sir, one question is it really required 3+1 AHU in CVT surgery room? What other option?
See, this I told you, this is being suggested by us consulting organization from Singapore for a particular hospital projects. See, these are guidelines. It is not a standards. But this is the method which can show that how it can be controlled. These types of 14 hours, 12 hours surgery, major thing is to control the pressurizations. And it should have a dedicated HU they are recommending, so that contaminations becomes less. Now, entire this, when I'm adding so many 3+1, these things, if we add, there will be a lot of ducting systems will be there, which is not possible to explain in this small area. I've told very clearly, this is our guidelines, the how these types of CVT surgery room to be maintained, to be made. If somebody thinks it can be done with a two, like, this is one AHU room can support the two rooms, pre-surgery and post-surgery. If somebody say, I will remove it, he can remove it. But these are all the guidelines.
Understood. Thank you so much, sir.
It will be
The
better if
next
somebody
question
asks
is,
me.
space is a
unmute.
challenge in the local hospital. Sir, I will read the next question for you.
Yeah.
From the question box. The next question is, space is a challenge in the local hospital. What do you suggest? Probably they are referring to the 960 square feet area you mentioned.
Just repeat once more. This is.
Space is a challenge in the local hospital. What do you suggest?
Same thing, 950, our NABH for Indian and ambience, they are saying that 400 square feet. Now, for these types of surgery, those who have experience of cardiovascular thoracic surgery, there's a lot of people are there, a lot of gadgets are there. So they are recommended that the infrastructure should be 950 square feet. So that, in this particular 950 area, there are plenty of gadgets. And the doctors needs to move around this place, nurses need to move to a place. That is why it is recommended for 950 square feet. You just imagine this, the surgery is taking place for 12 to 14 hours. So it is a recommendation. It is not that it is to be followed.
Understood. Okay. The next question is, inner metallic part should be SS316L or 306. Probably about the construction of AHU. Probably. I don't know.
No, it is not for the AHU. It is for the medical gadgets.
Medical. Okay.
Medical, there are a lot of
any specification?
I have mentioned there are one part which is called clinical facilities. Clinical facilities, tools, surgical tools and others, even some of the surgical, beds and others, there is a recommended. It is not for the HU.
Understood. So is there any specification? Any, like it should be 316L or 306?
See, in case of, all the surgery, this is the 306 is recommended.
306. Okay. The next question is from Mr. Anand VL. How much is the velocity? 35 FPM or 0.4 meter per second? Which velocity?
The two are different. The same thing is coming. Either 20 feet, what we say, it has been recommended by ISHRAE.
35 FPM or 0.4 meter.
This is the meter, if you say that will come. This is recommended. Either you say feet or meter.
Okay. Second question is whether outside of HIPAA plenum, additional air supply diffuser can be used to ensure ACPH.
Yes, that is I mentioned there. See, since this is a larger size of room, strapline diffuser is recommended. Apart from the normal, which the air which is coming through the HEPA, along with the strapline diffuser is recommended.
Okay. His next question is not 25 ACPH enough?
See, our ASHRAE guideline is set for a minimum 20-25 ACPH. But it is for the Americans Thoracic Surgery Associations, they are recommending for a higher ACPH because you see, it will take a lot of time to explain. These types of surgery is taking for 12 to 14 hours. And there are smoke densities are very high. So it needs, and since the patients remaining in a table for a longer hour, there is a chance of contamination. That is why it is recommended for a more air change. But again, I'm again telling you, there is no such written that it should be. It's a guidelines.
Understood. Understood. So whatever you quoted, generally they are all from developed countries like America, Singapore,
Yes,
etc.
yes.
Yeah.
See,
Understood.
in India, if you do a surgery within this types of cardiothoracic surgery in 300, 350, they cannot say anything.
Right.
But what we are discussing, this should be the international standard. This is followed. But is a guideline actually. There is standard laws not been formed that this will be the data dimensions.
Okay. Now, the next two questions are probably somewhat similar. I will read both. Probably you can answer together. Installation of 3 AHU is not possible in metro city due to height. That is one question related to AHU. Second question says, instead of multiple AHU, can we go with one AHU for airlock, pre and post surgery with a recuperator?
See, I have shown you that you have dedicated AHU to be kept for the airlock system. Now, this will take a lot of time to, if they can write to me, that will be better. Because you see why at least NABH also recommending a dedicated AHU for a surgery room. At least they have come to that level. Now, we don't want to disturb the main AHU with the HU which is creating the airlocks. Because return cycle air which is coming, it is go to the same surgery room which is using an HU. It has its exclusive return air duct. It will not mix up. That is why you don't want to mix up all the HUs together. It is a very specialized surgery. Because of this 12 to 14 hours, these contamination chances are very high. So if anybody say that I will make it all one HU to single HU with all the airlocks and everything, it is possible by web, but it is not recommended.
Understood. Understood. So if I interpret whatever Mr. Niladri has been saying, it is all from his experience. Working
and we have followed the guidelines of thoracic surgical of associations Society. Of US and the consultant of Singapore that we had worked for one hospitals. So this is the way the guideline has been made. There is no standard design has been formed for how the cardiothoracic surgery room will be made. It's a flexible.
Understood. So, meaning there is no, this is not to be taken as a standard or some implementation guidelines for India conditions. So, Mr. Niladri simply shared whatever they do
these types
in
of
America
design,
and Singapore.
It is not applicable for a cold country like North America or European country. It is for India, Bangladesh, Myanmar. There you can use it.
Good.
Now, I'm telling you, see, how many surgery rooms having a post-surgery and pre-surgery? But surgery is taking place.
Right.
It's happening.
Good point.
How many surgery rooms are having that?
Right.
So, if we say that this is the standard, no need of pre-surgery room, post-surgery room, airlock. How many airlocks are there in our surgery room? Nothing. Surgery room airlock to be created by the architect, and it is also an expensive. You are losing the space.
Right.
So what actually happening and what should be done, this is to be understood.
Right. Okay. The next question is there any standard certification available in India for hospital certification in terms of facilities?
See, as on date, for hospital, see, there are plenty of hospital consultants, hospital contractors, and HVAC consultants are there. As on date, we have not made any. We have discussed in ISHRAE also to make us certified professionals for hospitals design. But that is still now, it has not happened. There is a NABS, they have some guidelines. So that somebody is following, somebody is not following, but that is very thin line in terms of engineering. They are more deeper in case of clinical. So that certifications is still not there. It is people has to understand the subject, daily staying with the hospital system, experience with the handling of designs, and this is where it will develop as on date.
Great. Okay. Sir, there are requests on the chat box requesting your cell number to reach to you. Is that all right, or they should send a mail?
You can share my cell number, no issue.
Please say the number. I will put it on the chat box.
Yeah.
Could you give your cell number, sir?
98, write it down. Everybody can write it down. 98302 139 00. And mail ID, which is already there.
Already shared here. Niladri.
This is my mail ID.
Yeah, good.
So first thing is that you have to understand, one is called standard. Another is a guidelines. It is not a standard, it's a guidelines.
Guideline, yeah.
An experienced person can do it in a one way, another person can do it in another way.
Great. Excellent.
So as you are asking me now, why these three? It is not a standard. It is a consultant who have developed for a particular hospitals, non-Indian hospitals. He has found, but their expertise is saying that this should be.
Right. Excellent. So thank you so much, sir. There are no more questions. I think the participants may be reaching to you on your cell number or mail ID. So I want to
anybody wants to know more in details about the subject, again I'm telling you, because it is a very less time, so we are I couldn't explain all the details and others, because some questions are coming, why 2, why not 3, or 3 or 2. These only possible, we have a plenty of time. It is a whole day sessions. There it can be explained. What is the reason behind that? What is the reason behind that we are asking for a air change rate 40?
Great. Excellent. Thank you so much, sir. We come to the end of the program. So thank you so much for sharing your knowledge and wisdom with all the participants on this webinar. So I want to inform the participants, we will be again coming back to you with many more webinars related to healthcare, clean rooms, operation theater related design information. Maybe if possible, again bringing Mr. Niladri onto the webinar platform. So please stay tuned with all the information related to webinars coming from ISHRAE to your mail ID. We will connect again soon. Thank you so much for participation. Thanks for your time, all the participants. I also want to thank ISHRAE HQ Delhi team for providing the necessary coordination. And a big thanks to Mr. Niladri sir for sharing all his experience and wisdom. There will be a feedback form which you will be receiving. We request you to give feedback for future improvement and implementation.
I have seen one question called thermal plume.
Please go ahead, sir.
It's a very broad subject. Thermal plume is one of the important things in case of surgery. Surgeon film density. If they want to know more details, there is no problem. They can definitely reach to me either by my handphone or by email ID.
Excellent. Thank you so much, sir. We will be again connecting very soon. Thanks to all the participants and ISHRAE HQ.